The last kind of chart we're going to mention is a scatter plot. And a scatter plot shows a relationship between two variables. This scatter plot shows a relationship between temperature and the number of times crickets chirp per minute. It looks like, according to this data, that when it's about 70 degrees, crickets will be chirping. Um, Again, this is hard to read, but whatever that is on the x-axis. And it looks like that cricket chirps per minute go up as the temperature goes up. Actually, we'll come back and talk more about this problem in chapter 10, and we'll ask the question, does there seem to be a correlation between temperature and cricket chirps per minute? If there is a correlation, is it a linear correlation? Can this be modeled roughly by a straight line? And in chapter 10, we're going to find out, yes, there's a line that fits that data pretty well. It's not perfect, but most of the points are in close to that line. And so in chapter 10, we're going to talk about linear correlations. That's getting a little bit of ahead of ourselves right now, but just remember scatter plots show a relationship between two variables. Here are two scatter plots. One shows the relationship between the waist area and arm circumference of men. This shows the relationship between the weight and pulse of men. Which one seems to have a stronger correlation? Which one would fit a straight line better? Well, I think this one comes much closer to being modeled by a straight line than this one. This one looks more like a shotgun blast. So I would say that there's a stronger correlation between waist circumference and arm circumference. The bigger your waist is, the bigger your arm's likely to be. Then there is a relationship between pulse and rate. Um, I'll just say the stronger correlation is in the A part. Does this correlation appear to be positive or negative? Well, that line, which I dashed in chapter 10, we're going to call that the line of best fit. And the one thing I can notice about that line is that it has a positive slope. It's going uphill from left to right. So that relation seems to be positive. And what that means is the larger a man's waist circumference is, the larger you would expect his arm circumference that to be. Would it be reasonable to assume that a larger waist circumference causes a larger arm circumference? No. We said in an earlier section that correlation does not imply causality. Just because there's a relationship between two variables doesn't mean one is causing the other. All right, I said that was the last graph and I was wrong. There is one more, the time series graph. A time series graph shows data that's been collected over different points in time. This is the Dow Jones Industrial Average from the years, whatever that is, to whatever that is. Um, I honestly can't read it and don't want to redo the video just so I can read those tiny numbers. But it looks like this was a time from this year to this year that there was very steep growth in the Dow Jones Industrial Average. By thinking back at my retirement fund, I would say that's the years from, I don't know, about 1990 to 2000. Um, the Dow Jones Industrial Average was growing very rapidly, and then there was a small correction. And then in the year 2000, it started gaining again. If this graph went on to 2010, what would we notice? What happened about 2008, 2010? That's when the stock market crashed due to the housing bubble. And I don't know how far down it went. I'm not meaning for that to be precise, but there was a very steep drop there, the steepest drop since the Great Depression in the 1930s. So a time series graph shows a change in data over time. Now, in the previous edition of the text, bad graphs were listed in a separate section than they are in this edition of the text. Now this is still part of 2.4, but you need to be able to identify graphs that are misleading. And we've already talked about this just a little bit. Um, Different ways that a graph can be not representative of what the data is actually saying. For example, this graph shows number of drivers in fatal crashes in a given year, and it looks like that 20 to 24-year-olds had more crashes than in any other category. And that may or may not be true, but it looks like, let's see, 16-year-old drivers are safer driver than people in their 20s. Do you think that's true? Fewer 16 to 19-year-old drivers have crashes than 20 to 24-year-old drivers. It doesn't seem to, I mean, my gut says that that's not right. People have had a little bit more driving experience, 20 to 24, and I would think that they're safer drivers than these guys, but that's not what it looks like in the chart. This chart would also say octogenarians, 80-year-old drivers, are the very safest. And I'm not sure if that agrees with my gut either. But if you look at this left-hand axis, it's the number of drivers in thousands in each of these categories. Many, many more thousands of 20 to 24-year-olds had accidents than the number of drivers over 79 who had accidents. The problem that we've mentioned before is these are raw numbers, not percentages. There are many, many more 20 to 24-year-olds on the road than there are 80 people over 79 or people in their 80s or above. So we should not be looking at these raw numbers, these number of drivers who had crashes in each category. We should be looking at the percent of drivers who have accidents in each category. When you look at it that way, a much higher percentage of drivers in the 16 to 19-year-old category have accidents than the percentage of 20 to 24-year-olds which have accidents. That's more in line with what my gut says, because these guys just don't have much driving experience yet. And unfortunately, your highest percentage of crashes are these. I think on the previous graph it said over 79. I may have just been reading that incorrectly, but percentage wise, these folks over 75 or 79 have the highest percentage of accidents. So this is a much more accurate picture of driving records, and they're reflected in insurance rates. These 16 to 19-year-olds have much higher insurance rates than these 20 to 24-year-olds. Another thing that can cause a graph to have a skewed representation of the data, doesn't seem to be saying, it's not saying the presenting the picture very well. It's when your vertical axis doesn't start at 0. These are the incomes per capita of citizens of California and Nevada. And if we start that graph at 30,000 and just count by 1,000s, there seems to be a huge difference in the income per capita in California and Nevada. It looks like Californians are making maybe 10 times as much as those folks in Nevada, when actually there's only about a $2,000 difference. How can a $2,000 difference look that big? Well, if your vertical axis doesn't start as 0, it skews your impression of the data. Here, when our vertical axis does start at 0, you can see that there's a relatively small difference between 30,000 and 32,000. So always make sure that your graphs start with 0 on the vertical axis. This is a similar example. You may remember the case of Terry Schiavo several years ago. She was in a car accident and was left in a coma for decades. At some point, her husband said, we need to just remove the feeding tube, let her go. She hasn't had any brain activity in decades and she wouldn't want to live like this. Her parents were saying, you can't do that. That's our daughter. So the case went all the way to the Supreme Court, and the Supreme Court decided it was the husband's prerogative. He was the guardian of her, and so they allowed him to ask the care center to remove the feeding tube, and she did die very soon after that. But if we look at a graph of Democrats, Republicans, and independents and how they felt about the Supreme Court's decision to allow the feeding tube to be removed, it looks like Democrats agreed overwhelmingly, much more with the Supreme Court's decision than either Republicans or independents. Looks like maybe maybe 6 times as many Democrats agreed with the Supreme Court as did the Republicans. But that's just because your vertical axis doesn't start with zero. When the vertical axis does start with zero, you can see there wasn't a whole lot of difference between Democrats, Republicans, and independents on this issue. One last bad graph to caution you about is using three-dimensional pictographs to represent two-dimensional data. Both of these show the relative oil consumption between the USA and Japan. But if you use a barrel to represent that, then think of these as tin cans. It looks like I don't know, maybe 10 of these oil cans would fit into that oil cans. It's a much bigger difference than the actual difference between oil consumption in US and Japan. This reflects it much more accurately. Japan uses about 5.4 millions of barrels of oil a day, and we use 20 million barrels of oil a day. We're still using about 4 times as many millions of gallons of barrels of oil a day, but 4 times as much as them is not um, nearly as dramatic as this picture makes it look. So when you use three-dimensional objects to portray two-dimensional data, it can skew the picture of what's actually going on. All right, I want to give you one caution. Um, you have some problems in the homework where you're supposed to be comparing different scattergrams. Those are very difficult to see on the small screen. They're difficult to see on the small paper that I'm writing on, but on the homework, there's a button that you can click to enlarge these graphs. When you enlarge them, they're much easier to read. So make sure you click that button when you're trying to decide which of these 4 scatter graphs portray some data more accurately. Make them bigger so you can read them better. All right. End with a cartoon today, one of my favorites. I think assignment 4 is still the assignment for this section across all 1530 courses, but make sure you refer to your instructor's calendar to ensure that assignment 4 is actually what you have to do tonight. This is for my 1530 on ground classes. But one of my all-time favorite time series graphs shows my overall health increasing until the day that I realized I'm a grown up now and I can cook bacon whenever I want. Kind of took a plunge after that. You have a great day. Bye.